Hi everyone, it is Miss O'Neill here with something really exciting today. We have our very first science lesson with distance learning. I am so excited. Last time we talked about science in our classroom, we were talking about different states of matter, and we just wrapped up that unit. So we're going to start something not totally brand new because it is all related to each other, but something new, okay? We're on lesson number 28. We're going to be talking about how the bigger the mass of an object, the more force it needs. And we're going to talk about force in a second. And the strength and direction of a force has an effect on an object. Okay? That sounds really big and really complicated right now, but by the end of the lesson, you are going to be going, piece of cake, Miss O'Neill. So, I know I definitely got Colton's attention and anybody else who loves Star Wars or The Mandalorian like me when I said the word force. I'm not talking about the force like the Jedi force. I'm talking about force. Are you ready? Be my echo. Any push or pull on an object. You're going to say it with me this time and you're going to do the movements with me, okay? Force. Any push or pull on an object. One more time. Force. Any push or pull on an object. Awesome, wonderful. So, let's bring it back to way earlier in the year when we talked about this word, matter. What is matter? We talked about how pretty much everything is matter. Everything around us that we can see and touch and feel. This marker is matter. This magnet is matter. This whiteboard is matter. My ring is matter. My hand is matter. Everything we can see, touch, and feel. Really, really quick, in the place that you're learning right now, you are going to point to an object or a thing or a person or whatever that is matter. 3, 2, 1, go. Now something different. 3, 2, 1, go. One more thing that's matter. 3, 2, 1, go. Awesome. Amazing job. So today we're going to learn all about how matter is moved. Okay? Jake, you scared me. Oh, goodness. All right. Because this magnet is not going to stay on my whiteboard forever. It's not going to stay in this one spot. My whiteboard isn't going to stay here forever. Everything moves eventually. Okay? Awesome. So, physicists, scientists that work with matter use the word force to describe what moves matter or what keeps it from moving. All right, we use force to push or pull objects. So I'm going to have a marker. I want you to have a pencil or something in front of you right now. And I want you to push your pencil across your hand. Whoops. Or your table, wherever you are at. Just go ahead and push, but be careful not to make it fall. Now I want you to pull your pencil towards you. So I'm going to just go like this and move it so slightly. Awesome. Now I want you to grab something a little bit heavier. Push it away from you and pull it towards you. Awesome. That was a secret science experiment that you just did. Which object did you use less force to push or pull? The book or the pencil? Which one used less force? For me, was it my marker or my whiteboard eraser? For me, it was the marker. It's the marker because the marker weighs less. I don't have to spend as much effort pushing my marker than I do my whiteboard eraser. I don't have to spend as much force pushing my marker like my whiteboard. And I don't have to spend as much effort pushing my marker than like the table that I'm on right now. You need less force to move lighter objects and more force to move heavier objects. So if I'm pushing my marker, it's pretty light, right? It's not going to require as much force as me pushing like Jake across the couch or something. Awesome. So if I was going to have my marker in my hand and I was going to hold my hand like this, what would the marker do? You're right, the marker would fall off, and that's because the direction that I'm doing, or that I'm putting my hand in, and the force here kind of helps figure out where the marker is going to go. It's like if I had a soccer ball in front of me and I just kicked the ball, the direction that I kick the ball would determine where the ball would go. So if I kicked the ball in front of me, the ball would go straight. If I kicked the ball behind me, the ball would go behind me. Awesome. So this is where it gets kind of funny. There is such thing as using too much force. So let's have my whiteboard eraser here again. I have it in front of me. I'm going to use my other hand and I'm just going to push it a little bit, okay? Just a little bit. It fell, but that's okay. Retry, just a little bit. Awesome. I'm going to do it again. This time I'm going to use a lot more force. Are you ready? 3, 2, 1. It went all the way across my table and kind of, oh gosh, it made a mess of all those papers. Okay, whatever, it's all for science. Did I use too much force that time? Not enough force, or just the right amount of force? Yeah, I used just the right amount of force. No, I didn't. I used way too much force. That whiteboard eraser flew right across the table. So, okay, there we go. All right, now is the part of our science lesson where we do a little story time. We're going to do a quick review of everything that we have learned in this science lesson so far. So just go ahead and relax as I read along. When we move objects, we are using force. Force is any push or pull. We can push an object away from us, or we can pull it towards us. It takes more force to move heavier objects. Let's draw like a refrigerator here or something. Something like really big. This is what my refrigerator looks like. We need to use less force on lighter objects. So let's say that whiteboard eraser that I accidentally launched into outer space. We need to use more force to move a box filled with books than we need to move an empty box. So the size of the object doesn't matter, it's how much mass is there. Mass, do you remember that word? Not mass like we go to mass on Sundays, but mass like the weight of an object. All right. The direction of a force determines where an object will move. If we kick a ball, the ball will move in the direction our foot pushes it. If we pull a desk towards us, it will move closer to us. And the amount of force determines how far an object will move. The more force we use to kick a ball, the farther it will move. All right, wonderful job. That is it for science today. I hope you had a great time. I can't wait to do more science lessons like this. Many experiments all on our own, but still learning all about science and investigating forces and work together. All right, remember the whole point of today's science lesson. The more mass something has, the more force you will need. Force is any push or pull on an object. And the strength and the direction of your force determines where it will go. If I push this marker away from me, it will go this way. If I kick the marker behind me, it will go behind me. Okay? If I kick this marker really, really hard, it will make an even bigger mess of papers all the way over there than my whiteboard eraser did. All right, wonderful job. I love you a lot. I see you. Love you lots. Miss you a bunch, and I will see you later. Bye.